Hi there, everybody, and welcome back to an A&P2. This is going to be a lecture on the lymphatic system. This is chapter 20. All right, so let's see if I can get my camera set the way I want it here. Okay, so your lymphatic system has three basic functions. The first should be very obvious to you, and that is fluid recovery. As you recall from our conversations on the cardiovascular system, basically as the heart pumps during systole, the pressure into these capillary beds causes the capillaries to swell, and they're quite leaky, so fluid leaks out. Fluid from the capillaries leaks out and mingles in the interstitial areas here between cells and allows for your cardiovascular system and the fluid from the plasma to basically nourish these cells. Okay, they deliver, or I should say this fluid delivers oxygen, takes away carbon dioxide, delivers nutrients, takes away waste, and this is a major role of your cardiovascular system. Now, every time that happens, when your blood pumps into these capillaries and they swell and fluid leaks out, when your heart goes into diastole, when the ventricles relax, most of the fluid comes back into the cardiovascular system. About 85% in the grand scheme, but there is a small percentage left behind, and it's that small percentage that's picked up by the lymphatic capillaries and brought back into circulation. Okay, so the whole goal of the lymphatic system here, this initial point, is to take up excess tissue fluid, interstitial fluids if you will, and return that to the cardiovascular network. Now, along the way of doing this, there is a secondary effect, and that secondary effect deals with your immune system. Now, what you'll often see is when you're talking about the lymphatic system, it's kind of hard not to talk about the immune system, and then vice versa. Hard to talk about the immune system without talking about the lymphatic system. So these are kind of part and parcel with one another. And the reason for that is very simple. As fluid that is picked up by the lymphatic system, say in your legs, is moving through the lymphatic vessels back towards the heart to be dumped back into the blood supply, as this is happening, this is a wonderful opportunity to check this fluid for potential pathogens, for potential damaged cells, for random proteins that aren't supposed to be there, for what have you. So you have an immune function that goes along with the lymphatic system. And that is that as the lymphatic system is picking up excess tissue fluids and bringing that back into circulation, the immune system will be constantly checking that fluid and making sure that the only stuff that's in it is supposed to be there. Looking for things that are not supposed to be there, and then mounting an immune response as a result of that. Which is why, as fluid is progressing through, it has to pass through multitudes of lymph nodes. And lymph nodes are basically a barracks full of white blood cells that are defensive. Okay, very important. And then last but not least, another functional lymphatic system that we're going to deal with when we get into digestion, and that is that your lymphatic system is heavily involved in the absorption of lipids from your intestines when you are digesting foods. This is through structures that are referred to as lacteals. They're found in the villi of your intestinal tract, and we'll be talking about those here in just a second. Hang on, I skipped through. There we go. So lymph flows in one direction. Is absolutely true, and that's sort of a foreboding thing. The idea here is that your lymph nodes, I should say, your lymphatic vessels, all of these, they are heavily invested in valves, some more than others, but we'll talk about that as we progress. But there's a lot of valving with the lymphatic system that allows for fluid to only pass in one direction, that is towards the heart. All right, so the first of the lymphatic system parts that we're going to discuss are the lymphatic capillaries. All right, lymphatic capillaries are known to be incredibly permeable. In fact, for a long time, it was thought that they were just open-ended, basically like big holes that fluid drains into from the body and moves back toward the heart. They are very good at bringing in even large materials, big cells, and getting those into the lymphatic system to progress through the body. Again, this would be part of the immune response. The idea is as follows, however. They are not open-ended. They are actually closed-ended capillaries, but these closed-end capillaries are special because they display what are referred to commonly as mini valves. The idea is that the endothelial cells that make up your lymphatic capillaries sort of overlap like so. And when there is increased pressure, all right, from like your heart beating, for example, when your heart beats and your lymphatic capillaries pulse with pressure and vent fluid, when fluid builds up in the tissues, it causes these vessels to be pushed open at these flaps, All right, so the vessel would be pushed open and fluid can go in, and then when the pressure comes off during diastole, the valve closes and traps what we'll call lymph, this fluid that flows through the lymphatic system, right? So this is very important for us. These lymphatic capillaries are very permeable. They are good at picking up excess tissue fluids. They are valved. They have these mini valves in essence, again, that can open up and close, and they will pick up material and bring it back into cardiovascular flow. Now, there are ways of speeding this whole system up as well, and one of the main ones that is worthy of our consideration is that of inflammation. Okay, so when you have histamine in the system, as an example, you're going to have a lot more fluid flowing towards the area, and the area will swell, generally speaking. And as this happens, the openings on these mini valves will open more so to allow more fluid to progress through the system, and even picking up larger cells. Think about like bacterial cells and even larger, to allow them to get into the lymphatic system so that we can warn your immune response, basically, so we can keep ourselves healthy. This is part and parcel with how this works. And then last but not least, in terms of parts and pieces of these lymphatic capillaries, lacteals fall into the realm of lymphatic capillaries as well. So lacteals, again, are found in your small intestine, and I'll be showing you images of this as we progress. But when they are here, they will be involved in taking up lipids from the foods that you consume. So what happens is this: when you are digesting food and it gets into your intestinal tract, that food stuff will have any lipids there dissolve using bile into the polar molecules, the polar fluids that make up the chyme that flows through your intestinal tract. The idea is that lipids are supposed to be non-water soluble. They don't bind to water, but bile is an emulsifying agent, so the bile will dissolve these lipids into solution, and then the lacteals take up this dissolved lipidy solution. And that's why they're called lacteals, because for a long, long time, we didn't fully understand what was flowing through them. We just knew that it looked milky white, so we called them lacteals, like it was milk-based or something along those lines. In fact, you can see here, this is a horse, but you can see in the mesentery here, these lines progressing through. These are vessels from the lymphatic system that are picking up the fattier portions of whatever this critter's been eating, and you can see the light color to it. So this is why these are called lacteals. Lacteals is a milky white solution, especially if you've been eating foods that are fatty. All right, good. So your lymphatic system does indeed have a lot of valves. It's very important, but also equally important is to realize that your lymphatic vessels are basically structured in the same way as your arteries and veins. Okay, they have the same basic tunics. It's the same basic setup. They are set up in the same fashion as your blood vessels. They basically look like veins in the grand scheme of things. All right, so there are indeed lymphatic capillaries, as you can see over here on the left-hand side. Those lymphatic capillaries lead to lymphatic collecting vessels. Okay, and the collecting vessels are very important because they are heavily invested with valves, again, preventing backflow. And next we have lymph nodes. So the collecting vessels will pass into lymph nodes. Those lymph nodes will be testing fluids, looking for potential pathogens and issues therein. That will then have fluid pass into lymphatic trunks, which are simply larger lymphatic vessels, as you can see here, and those will terminate into one of two major lymphatic ducts. Let me say that one more time. You have two major lymphatic ducts. These are the right lymphatic duct and the thoracic duct. All right, the right lymphatic duct and the thoracic duct. The right lymphatic duct drains your upper arm and the right side of your head, etc., whereas the thoracic duct basically does the whole rest of the body in its entirety. Okay, so where do all these end up? Well, they end up dumping in right at, or above, I should say, your superior vena cava. I'll show you that here in just mere moments. And, well, let's just go right to it. All right, so what you can see here, this is the superior vena cava. And coming down from this, we've got our subclavians and our jugulars. And basically at the junctions of the subclavians and the jugulars, this is where your right lymphatic duct dumps in on one side, and your thoracic duct dumps in on the opposing side. Okay. Now there are a few other interesting nuances to talk about here. One is the cisterna, okay, Keeley. okay? Kylie, Cisterna Kylie. Full disclosure, my amazing anatomy professor back in the day, she called it the Cisterna Chi, okay? But I think the appropriate enunciation, so this word here, fatty lymph absorbed from the digestive organs, so the lymph that comes in via the digestive system is called chyle, like a name, okay? It's the name Kyle, it's chyle. So the Cisterna Kylie, I believe is how it's supposed to be said. But you may hear me say Cisterna Chi at some stage. It's just because that's the way I was raised. So what this is a big merger down here, this big sac. Not everybody has one of these, but most people do. It's this big merging point where all the large lymphatic vessels from the legs, for example, are coming in and sort of connecting in unison to one another. So it's from the lower portions of the body, and then that would, of course, turn into the thoracic duct and lead up into the venous network. And it's kind of important to point this out. You can see this big swelling here that is the Cisterna Kylie, and as it moves up, the duct itself is much smaller. What you're going to find is that this is very common. What we want is for lymph to travel slowly. The body takes steps to make sure that lymph goes slow through this system. And the reason that we want lymph to travel slow is so that anything that's in the lymph can't just kind of slip through your lymph nodes unnoticed. If it's in the lymph, we want to make sure that we pick it up and check on it to make sure it's supposed to be there. So this whole system is kind of set up for lymph to flow slowly. Okay, chyle, fatty lymph absorbed from the digestive organs, absolutely. So that would contain fat. All right. Lymph transport. So your lymphatic system is non-heart associated. So the pumping of the heart moves blood, and the movement of blood certainly does apply fluid that becomes lymph. But the pressure from the heart certainly does not propel lymph through the system. There is no pump associated with your lymphatic system. So the flow of lymph is a lot like the flow of blood through your veins, but with some minor tweaks on the system. Now, this should all sound very familiar. Skeletal muscle milking. So the act of skeletal muscle to squeeze your lymphatic vessels and move lymph in that fashion. Your respiratory pump. Okay, so every time you breathe, there is pressure generated there that pulls blood back up towards your heart, or in the grand scheme, towards your superior vena cava. There are certainly a lot of valves. These lymphatic vessels are heavily invested with valves, and they're going to prevent backflow. And then there are some nuances to this. So close association with arteries. A lot of these lymphatic vessels are closely located with arteries. So as blood pumps through the arteries, and the arteries are pulsing as a result of this, that pulsing in the artery pressing up against the lymphatic vessel will help to push lymph back towards the superior vena cava. And yeah, let's see, smooth muscle, and not that terribly concerned. It's the general ideas here. And of course, any increased activity levels will certainly speed up lymphatic transport. The idea is if you start to get up and run around, then your skeletal muscles will be pumping more, your respiratory pump will be working more, your arterial network will be pumping more, and all these things help to move lymph back towards their interaction points with the cardiovascular system. But again, making a point here, this system is quite slow. And the reason it's slow is because we want lymph to travel slowly through your lymph nodes so that anything in there can be dealt with in a timely fashion. Yeah, sounds good. A lot like your venous system, a lot like veins. All right, let's talk a little bit about the lymphatic cells. So there are sort of the top one, and then these three are similar to one another. The top one here are the reticular cells, or what we'll call typically reticulocytes, reticular cells. These produce a fibrous network of reticular fibers. Reticulocytes, I should say, produce reticular fibers. And the idea behind this is very straightforward. You pretty much exclusively see reticular cells making reticular fibers in the lymphatic system. And it is these reticular fibers, like in your lymph nodes as an example, that form up a web in which things like macrophages, for example, will be hanging out, acting like little spiders in the web so that anything flowing through can be trapped and destroyed. So imagine there is fluid flowing through a lymphatic vessel and it gets into a lymph node. that lymph node is going to have a massive net, a web, if you will, of reticular fibers made by reticular cells that can trap anything flowing through that lymph node. And then things like macrophages, as an example, can find these foreign substances trapped by these reticular cells and their fibers and attack and destroy them. Okay, so this is a very important nuance, is that there are reticular fibers here that act like a net. All right, next we have macrophages. Macrophages are like the most prolific phagocytizing white blood cells in your body. They cruise around. They're very simplistic. They're like the infantry. They go through, they find anything that's not right, and they take care of it. All right. They are also involved in activating T lymphocytes. So when a macrophage destroys something with antigens that it doesn't like, it will basically show those antigens to T lymphocytes, and then those T lymphocytes will become activated and be very violently dangerous with anything that's not supposed to be there. Think of T lymphocytes as your special forces. Let's jump down here to dendritic cells and do it next. So dendritic cells are very similar in this. They're a lot like the macrophages in the grand scheme. They will capture materials that display certain antigens and go into the lymph nodes and show it to T cells, basically. They will activate T cells. So they will capture foreign antigens, carry that to the lymph nodes, show it to T cells, and then the T cells go hunting. All right. Next, let's talk about the various types of lymphocytes. These lymphocytes are the primary cells that we're going to be dealing with here, and there's a whole variety. And folks, I'm not going to go into detail on these right now, but when we do the immune system, you can rest assured you're going to become best friends with all these. Things like natural killer cells that attack bacteria. Your T lymphocytes are just amazing, very talented, very good at identifying very specific pathogens and dealing with them. Your T lymphocytes are very special. You have B lymphocytes that will turn into plasma cells, and the gist of this is that they crank out antigens at an incredible rate. And antigens, if you don't remember from doing blood, antigens are proteins that mark cells for death. So when an antigen, or I'm sorry, antibodies, oh, geez, I've totally messed that one up. The idea of plasma cells is they make antibodies, and antibodies bind to antigens and mark foreign cells for death. So if I've got a bacterium, it's going to bear foreign antigens, and I'll have a plasma cell that cranks out antibodies that'll mark that pathogen to be destroyed, typically by T lymphocytes. Man, that was kind of a roundabout way to get at it, but that'll do. Let's see, lymphatic tissues. So there are a variety of different lymphatic tissues, but I'm just going to jump straight down here and give you an idea of what we're dealing with. Man, let me tell you, you've got lymphatic tissues all over the body for a reason, and that is that it's good for your immune system to pick up potential pathogens early to be able to deal with them. So when you're looking at any lymphatic tissue, you're going to see these weird darkish spots. Like, just look for them. You'll notice them, round spots. In any tissue you're dealing with, you're going to see these weird little dark spots, and that is part of your lymphatic system. Those are referred to as germinal centers. These are areas where you're going to be making primarily B cells become active. All right, so your lymphatic tissues are a site for the housing and proliferation of lymphocytes. It's absolutely true. And two, they provide a fibrous network that your immune cells can kind of hang out in and look for potential pathogens. Now, in the grand scheme of lymphatic tissues, there are diffuse lymphatic tissues that are just all over the place, scattered all over, being used by the body to pick up potential issues early. And then there are your lymphatic follicles, okay, things that are referred to commonly as nodules. These are bits of lymphatic tissue that are more centrally located, like around your lymph nodes and what are called Peyer's patches. They'll all have germinal centers where B lymphocytes will be setting up shop and doing their job. All right, now, before we move forward, let me make a point. Your lymphocytes are going to be made in your bone marrow. They're going to leave your bone marrow. They're going to go out into your bloodstream. They're going to cruise through the bloodstream and eventually leave the bloodstream and enter the lymphatic system. Okay, they're going to cruise through the lymphatic system, probably make their way into a lymph node, and then they're going to hang out in that lymph node for a period of time. But eventually they will break loose and go back into the bloodstream, and the whole system starts over. You got to think about all of these lymphatic cells, okay, like B lymphocytes, T lymphocytes, what have you. You got to think about all these lymphatic cells as being on patrol. They're looking for pathogens that they can then deal with. Okay, they're looking for pathogens they can deal with. So they're constantly moving through your tissues, moving through your bloodstream, moving through your lymphatic system. Okay, very important. Lymphoid follicles. So in the realm of these nodules, these follicles, if you will, there are a few things that are worthy of our conversation. The first thing I'm going to mention are what are referred to as diffuse placements of various lymphatic tissue, and the term that you always hear is MALT. Okay, that is mucosa associated lymphatic tissue. This is bits of lymphatic tissue that are found all around the body. Okay, like here, these are called Peyer's patches. I'll show you some more later, but you can see these weird little spots, right? See these little spots? These weird little spots. That's areas of lymphatic tissue, of MALT, of mucosa-associated lymphatic tissue, where you're going to have particularly things like B lymphocytes hanging out looking for problems. Okay, hanging out in there looking for problems. And the reason you'll oftentimes see like these deep troughs down in here like this is there will be little bacterial traps. And these bacterial traps will capture bacteria, and then we'll use that captured bacteria to basically test our immune system, to show our immune system what's around, so they can develop memory cells that will help us to deal with problems basically before they arise. Okay, and that is indeed how that works. So just be thinking about these deep crevices in your lymphatics as a trap, if you will, and that trap is going to be used to capture these bacterium so that our other white blood cells can come in and look at what's there and then develop a strategic plan basically to deal with them in the event they become a problem. Okay, where our immune system, we start off naive to certain strains of organisms and their antigens, and we're going to use this to develop memory so that our immune system can then respond very strongly if necessary. All right, so in the realm of MALT, there are indeed things like Peyer's patches. As you can see here, this would be mucosal-associated lymphatic tissue, and it's all over the place, man. Your tonsils, it's all over the place. Your appendix is an example of MALT. So surrounding your appendix is a bunch of lymphatic tissue, and the thought is that this little blind-ended appendix will have bacteria from the large intestine collect in it, so that your immune system can constantly test your intestinal flora and look for anything that's a problem. Okay, that can develop a memory cell or a group of memory cells to deal with that pathogen in the event it ever has to. So these are early warning systems is the idea. It's really what's thought of as a calculated risk. All right, further in the realm of your lymphatic follicles and or nodules, these bits of MALT, okay, what we'll have are things like the tonsils. Okay, tonsils are a really good example here. This is simply lymphatic tissue that's located at a orifice of the body, being your mouth, that is looking for potential pathogens as an early warning system. So think about the air you breathe, the foods you eat. These are all sources of potential problems. So the reason you have tonsils is to look for those problems and to give your immune system an early warning. So your tonsils, for example, have what are called tonsillar crypts. These are deep areas where material will get and embed itself. The idea is you're kind of inviting bacteria in or other potential pathogens. You're trying to bring them in on purpose. And again, this is like a calculated risk. The goal here is to expose your immune system early so that you're no longer naive. The idea is your immune system can be naive, where it has no idea what's coming. It doesn't recognize any antigens, which can lead to a major outbreak of a pathogen before your immune system has a chance to respond. Or alternatively, you could develop memory cells early on that can then release antibodies to antigens the moment they arise. So what we're doing here is we're exposing the immune system on purpose so we can develop memory cells that can then lead to a very fast immune response as time progresses. And I'm just kind of trying to lay this on you gentle at the time being, like for now, because later on, when we do the immune chapter, this will make way more sense. All right, this will make way more sense. Right now, we're just trying to approach it from the lymphatic side. There are a variety of lymphatic organs. So there are primary lymphatic organs, and we call them primary lymphatic organs because they are where the lymph cells themselves arise. So you have your bone marrow. Your bone marrow gives rise to both B cells and T cells. Like all your blood cells come from your bone marrow, so both B cells and T cells. And the thymus is also considered primary lymphatic tissue or a lymphatic organ because this is where your T lymphocytes mature. Okay, man, let me tell you, this is a can of worms of a conversation to have here, but the idea is as follows. Your T lymphocytes, and I'm probably jumping ahead here, and if I am, that's just life. Just, you know, pay attention. If we get there and it's the same thing, then that's fine. Your T lymphocytes are powerful, man. They're very powerful anti-cell white blood cells. Okay, they are very good at damaging and destroying cells that are either marked for death, have potential problems like a viral interaction, you name it, bacteria. Your T lymphocytes are pros at attacking and destroying them. But they are so good at killing cells that they're a little scary. Okay, so what we do is we make them in their immature state in the bone marrow, and then we send them out into the bloodstream where they make their way to the thymus. In the thymus, okay, we call them T lymphocytes because they're thymus associated. In the thymus, they mature, okay, and the thymus will begin to crank out what are called immunocompetent and generally speaking capable T lymphocytes. It'll start cranking them out slowly over time and helping to basically develop your immune responses, okay? Now, this is very large in the young, so very young individuals. I think about 1 and 2 year olds, the thymus gland is quite large. It is still of a decent size when you're a teenager. You're still cranking out pretty large quantities of these T lymphocytes. But then as time progresses, as you age, it gets smaller and smaller. By the time you are middle-aged to late age, if you will, so think 60, 70, 80, the thymus gland is pretty well gone, and it's basically replaced by a bunch of scar tissue. So you'll be releasing a very few T lymphocytes still at this stage, but very few, okay, is the key word here, very, very few. Whereas when you're young, you're cranking out large quantities. And we'll talk more about why that matters a little bit later on when we do the immune system. Oh, a neat little point. There is a blood barrier. So your brain has what's called a blood-brain barrier. Well, your thymus gland has a blood barrier as well. Your brain, boy, this is a lot of weird letters here, folks. Your brain has a blood barrier because it's trying to keep foreign materials in the bloodstream from getting in, whereas your thymus has a blood barrier because it's trying to keep certain T lymphocytes from escaping. Okay, sometimes you have T lymphocytes that are just a little too aggressive, and they would go out into the body and lead to what are called autoimmune diseases. The goal of the thymus is to have a barrier in place to prevent those white blood cells from getting out and to then destroy any of these T lymphocytes that don't have the capacity to recognize self versus non-self. Okay, it's called self-tolerance, and we'll talk more about that later. All right, then there are secondary lymphatic organs. These are going to be areas where your lymphocytes have their first antigen encounters, where they can develop this, we call it memory, if you will. All right, your spleen is one of these. Your spleen is very important. It's got a bunch of macrophages in there that help clean out the blood. That's true. And your spleen is important because it's an incredibly tough organ. I'll be talking more about this as we progress. But the essence of the spleen is that it can become highly damaged and completely regenerate if it needs to, especially when you're young. And it is certainly considered a secondary lymphatic organ. Now, an important point here is the spleen gets lumped into lymph nodes all the time because the spleen internally looks a lot like a big lymph node, but it is not a big lymph node. The spleen is a standalone unit, and it only has blood flow to it. So it'll be dealing with your lymphatic cells, but only because they are flowing in and becoming lymph in there, okay? So your spleen only gets blood flow. It does not have flow to the spleen from the lymphatic system, only from the spleen to the lymphatic system. So there are no afferent arterioles to the spleen from your lymphatic system, only efferent, only leaving it. Whereas your lymph nodes have afferent arterioles coming in and efferent arterioles, or lymphatic vessels, I should say. I don't know why I'm saying arterioles, going out. All right, good. I think that'll do. Lymph nodes themselves. All right, lymph nodes. You have hundreds of these, and they are located all over the body. But generally speaking, you see more of them in areas where structures are connecting to the torso. So you see a lot in your neck. You see a lot in your armpits. You see a lot in what are called anogenital regions, i.e. where the legs connect to the torso. And when they are swollen, this is a classic example of some sort of bacterial infection. All right. And again, give me time. We're going to talk all about it. Built into this, these secondary lymphoid organs are like lymphatic nodules. These are your MALT, okay, that mucosa-associated lymphatic tissue, tonsils, and what have you. And your Peyer's patches fall into this realm also. I wanted to show you the Peyer's patches a little more detailed just because I think they're really cool. So what we have here is the intestinal tract from the stomach all the way down to the rectum. Okay, and what will happen is the stomach empties material into the duodenum. That material empties into the jejunum, so the duodenum's kind of short, into the jejunum. The jejunum's where most of your absorption is going to be taking place as well. The ileum is here, and the ileum is where you find Peyer's patches. That's sort of like how you identify ileum versus jejunum. One of the main ways is you look for Peyer's patches, these bits of lymphatic tissue. Again, look for these weird, random color variations. You can see it, okay? These germinal areas, these are germinal areas. You can see them plain as day. This is classic lymphatic tissue. And the reason that the ileum has Peyer's patches that are lymphatic tissue is because the ileum connects to the large intestine. So your large intestine is flush with bacteria, man. There are bacteria all in the large intestine. So we have this lymphatic-associated tissue in the lowest portions of the small intestine to make sure that nothing is getting into the small intestine that shouldn't be there. Okay, it's just yet another way of providing immune surveillance, of developing memory just in case something becomes a problem. And if you don't know what an appendix is, there's a nice view of an appendix right there. Yet again, mucosa-associated. So let's talk in a little bit more detail about the spleen. It's kind of a neat structural set. And let's see, how deep do we want to go here? So you can see the splenic arteries coming in, and as you go into this, you can see these areas in this cross-section of the spleen where you have what are called white pulp areas and what are called red pulp areas. So the red pulp, you can see in red here, and the white pulp areas you can see kind of in a lighter color here. When you look at a real spleen micrograph, it's going to look something like this. So the areas of white pulp will be these kind of darkish areas that are not unlike these Peyer's patches here, and the red pulp areas are in between. And the usage here is very straightforward. The red pulp is the area that deals with the filtration of red blood cells. If you think back to our conversations on blood and blood flow, we talked about how the spleen cleans out old red blood cells. Okay, so that's going to be the role of red pulp here, but also in the spleen we have white pulp, and white pulp is part of the lymphatic tissue. Again, think about the intestines. Here's the intestine. Here is this area that's a lumen for carrying materials through for digestive purposes, and then we have areas for lymphatic function. So in the spleen, we've got areas for dealing with red blood cells, which is kind of the role of the spleen, and then we have these areas with white pulp where we're going to be dealing with immune responses. And that should be a close parenthesis. All right, let's see. What else do we want to say here? So other unique attributes. So the spleen, just for kicks and giggles here, the spleen certainly stores platelets and monocytes, and then will release them when necessary. So it plays that role of storage. We think that the spleen may play a role in making red blood cells in a newborn, like a fetus, basically. Very young individuals, the spleen may play a role, much like red bone marrow, in the production of red blood cells. And then last but not least, quote, crazy regenerative capacity in younger individuals. Your spleen can rupture. It's the area in which it's held, which would be kind of over in this area here, all right? Sort of right in there, really. The spleen is easily ruptured if it takes a direct impact, and it can bleed, which early on we thought was really bad, but now we sort of realize that the spleen is really good at healing itself. In fact, you can have the majority of the spleen completely destroyed when you're young, and it will regenerate from just like a nub of splenic tissue. So it's got a really incredible regenerative capacity. Man, figure out how that works and make the liver do that, and you're going to make some serious money. Or, figure out how that works and make the heart do that, and you could probably make some serious money. It's a weird thing in the body to have an organ so capable of regenerating. Like your kidneys can't do it. Like, it's a rare thing. All right, on to the thymus gland. We've, again, already kind of talked about this. The thymus gland sort of sits on top of the heart in that area, I should say, when you're very young. And it's quite large when you're very young and bilobed. It kind of looks like this. Okay, it kind of has two sides to it, lay on top of the heart. And it is in the thymus gland that T lymphocytes mature. Okay, it's got nothing to do with B lymphocytes, and it doesn't make T lymphocytes. The T lymphocytes just head to the thymus to mature. The thymus gland is important because it does indeed have a blood barrier that acts a lot like your blood-brain barrier, but again, your blood-brain barrier is to keep stuff out, whereas the blood barrier in the thymus is to keep stuff in. Okay, we are corralling your T cells until we know they're not going to hurt us, basically. Let's see, what else do we want to say here? I'm pretty happy with that. Yeah, I'm pretty happy with that. Let's just leave that there. Again, my goal here is to make these lectures not as long as I've been doing, so let's just keep moving. Lymph nodes. Oh man, what? Here we go. So lymph nodes are incredibly important. They are indeed the rest stops from which lymph moves through on its way back to the heart. So you've got lymph nodes all over the place. Okay, you've got lymph nodes all over. And you can see them here in this mucosal tissue. These are all little lymph nodes as they're moving through. And in your system, the largest lymph nodes you have are about an inch in length. Most of them are smaller than that. Now, lymph nodes have two major functions. And those two functions are, one, filtration, which is the main goal here. As fluid moves through the lymph nodes, it's constantly being tested by your macrophages and dendritic cells and all these others that are hanging out in there. They are looking for potential pathogens. And by doing this and stopping stuff along the way, we are stopping the delivery of pathogens into general blood flow. Okay, that's the idea. We want to stop stuff before it can get back into the bloodstream. Then number two, immune system activation. When our immune cells pick up antigens in the lymph nodes, they will basically display these antigens to all the other lymphocytes that are in the area and say, hey, this is what we're looking for. Here are the antigens. And that will activate your T cells to go out and do work. Okay, now, and another nuance to this is that your lymph nodes, as I said previously, have both afferent and efferent lymphatic vessels. The idea is that lymph flows into your lymph nodes and then flows out through this area called the hilum. Not that it has any bearing on our conversation, but hilum means a little trifle. So this is supposed to be like a little spot. It's a little spot on the lymph node where the lymph leaves. All of this is valved, by the way. You can see it's all valved. Let's see, what else do I want to say here? Packed with B cells, surrounded by dendritic cells. Yeah. I will point out that the flow through a lymph node is very slow. Okay, very, very slow. You have, and I'm sure I talk about this later, but you have only two here, no, I had it right the first time. Two efferent arterial or lymphatic vessels and lots of afferent vessels coming in. So lots of lymph is flowing in, very little lymph is flowing out. And the idea is we want the flow through that lymph node to be very slow so that as fluid comes in, your white blood cells that are hanging out in there can look at anything in the lymph and deal with it accordingly. Okay, this is a protective measure. We want a slow flow of lymph. All right, let's see. What else do we want to say here? I probably have already told you everything you really need to know. Let me take a look. So you've got a fibrous capsule around your lymph nodes. This fibrous capsule invaginates into the lymph node and forms these trabeculae, basically sectioning off. So you'll have individual little sections inside the lymph node. So as fluid flows in, it doesn't distribute equally all throughout the lymph nodes. It's sort of going to be tested here, then tested here, and then tested here on its way through. So there is indeed, I should say, a capsule surrounding the lymph node, and these trabeculae that section off the lymph node, they kind of subdivide the bits internally, makes little compartments in the grand scheme. There is a cortex and a medulla, much like your brain. So a cortex is around the outside. The medulla is the internal portions here. The cortex, you can find all these germinal centers, lots and lots of B cells found there. Whereas the medulla, more inward, is going to be more T lymphocyte associated. Okay. Let's see, what else do I want to say here? We also worthy of mention are these sinuses. You can see sort of deep in the core here, these kind of open areas. These are referred to as medullary sinuses or lymphatic sinuses. These are areas where there are piles of macrophages just hanging out. Okay, so you got to think about it like this. You got lymph flowing in. That lymph's going to flow in. It's going to come into contact with lots of B cells, lots of T cells. And if they don't respond, then deep in the core of this thing, it's just like packed with macrophages. So anything coming in that's a foreign particle, it's got foreign antigens, you got white blood cells just lining this thing, man. These lymphatic sinuses and their macrophages, just lining it to be able to deal with anything that's coming through. Let's see. So we have afferent vesicles coming in. They're going to be carrying lymph in. That's going to go into the subcapsular sinus area, into these medullary sinuses, through the lymph node and out the hilum and into your efferent lymphatic vessels. This basically just makes the lymph node a filter. The idea of the lymph node is that it is indeed a filter. Any sort of foreign pathogens that are there, any foreign antigens that are presented, they will be picked up and dealt with accordingly. Yeah. Is that all I want to say here? The main concept is that we're going to activate an immune response. Let me check one more thing, make sure. Yeah. So I'm not sure if I talked a whole lot about this, but sometimes your lymph nodes might become swollen. When lymph nodes swell, that's because there are white blood cells piling in to do battle with some sort of foreign pathogen. A swollen lymph node is a classic example of a bacterial infection. If you have a bacterial infection, the lymph nodes in the area of that bacterial infection will become quite swollen. So when you've got bacteria in your system, they're going to get into your lymphatic system in some cases. They're going to flow through, get trapped in your lymph nodes, and then your lymph nodes will pick up those foreign antigens, call for help, and there will begin an influx, if you will, of white blood cells to deal with that pathogen. You're having a major immune response, in essence. And that's what the lymph node's for. Okay, that's why your lymph nodes might swell sometimes and become painful. The pain is just because the lymph node gets larger. And when the lymph node is enlarged as a result of piles of white blood cells, flowing in, that puts pressure against your receptors in the area, like nociceptors as an example. And that means that any further pressure elicits a nociceptive pain response. All right. Let's talk about some weird other nuances that play a role with your immune system and your lymphatic system in particular. And one of those is Yersinia pestis, man. Good old-fashioned bubonic plague. So this killed, what, like a quarter of the population in Europe back in the day? In some cases, like a half the population of Europe. So huge numbers of people. So this is a bacterium that is passed by blood-to-blood contact. And the way that they moved around is that a flea would land on a rat that had an infection from this bacterium, and then that flea would jump off the rat and get on a person, bite that person, and that person would get bubonic plague. Okay, this is bubonic plague, the Black Death, as it were. It is called bubonic plague because it results in what are called buboes. These are big swollen lymph nodes from massive numbers of bacteria being trapped in the lymph node, basically clogging it up, leading to mass problems, and the eventual death if you don't treat it. This is very fatal indeed. And again, the reason we call it Black Death is because bits of the body will go into necrosis and die. So it's Black Death. Terrible, bad way to go. And then, just as kind of like a public service announcement, I want to talk a little bit about lymphangitis. So this is a inflammation of the lymphatic system, and this is typical of some sort of really nasty bacterial infection. All right, this is so dangerous, man. I'm trying to point this out to you because it is terrifying. This is something where you go to the emergency room. Like, I tried to find the details on this picture, but I just couldn't do it. It looks like a little bitty fella, and it's scary. Golly, it's scary. Like, I would freak out. So what I want you to notice is you can see like a bite mark, classic spider bites from my perspective, and then look leading away. See the red streaks? There's something in there so nasty that it's inflaming the lymphatic vessels. And when the lymphatic vessels become inflamed, you can see the red streaks. Classic red streaks leading back to the heart. Man, let me tell you, this spreads fast. It becomes critical quickly. You got to get to the hospital when you see this taking place. This is not an ideal situation, not something you want to be dealing with by yourself, all right? So, public service announcement, if you see some sort of bacterial infection or damage of this fashion, and you can see these streaks leading away from it, that's something you want to have taken care of sooner rather than later. I think that's it. All right, that's it. All right, thank you so much, folks. I hope you got a little bit of enjoyment out of our little lymphatic chapter here. Pretty straightforward, simple stuff from my perspective, and we'll see if we can't dive into immune responses in a little bit more detail pretty soon. All right, thanks.